Okay, so let's get started. This is section 6.2. Now we are going to look at how to, apply those the area of normal distribution curves for real life applications. So now you remember the last time we had, how to find the area of, the given standard normal distributed curve. Now here we are going to look at, in general, how to find the area between two corresponding normal distributed variable value. Okay, so there are two procedures here I'm going to explain. Let's look at this procedure table first. Find the area under the any normal curve. This is different than the previous section. In previous section, we had the area recall. In the previous section 6.1, so we had finding area of standard normal curve, z distributed curve, right? Z curve. So we had standard normal curve. Okay, so you'll be given there you had the variable z, and we had there you had two different values, and we found the area, right, in 6.1. Now here in 6.2 we are going to find the area between two normal distributed, you know the curve values. Here now we are going to look at just a normal distributed. Okay, okay, so here again we are going to find the area like this. Okay, so this is the area now we are going to figure out how to find. So the first procedure says that, so first to draw the normal curve with the desired area, whatever the area you need to figure out. Then convert that x means the normal distributed variable into standard normal, into z. But we already have the relationship between the standard normal and normal. Use that formula and convert your the corresponding x values into z values. Once you have a z values, that is a standard normal, then you know how to find by either using calculator or by using table. Remember, the table always will be for standard normal, not for the normal. So if you want to use the table values, first of all, you need to convert your x values into z value by using the formula z is equals x minus mu over sigma. Remember here where mu is the mean of the random variable x, and sigma is standard deviation of x. Okay, so convert that, and after that find into by using a calculator or any other software. So let's look at this problem. Look at this example. An adult has an average of 5.2 liters of blood. Assume that the variable is normally distributed and has a standard deviation of zero point 0.3. Find the percentage of people who have less than 5.4 liters of blood in their stream system. Okay. So now here the thing is, first of all, you need to identify the variable. So they're telling that, assume that the variable is normally distributed. They're talking about, the blood amount in, blood amount in the body. Therefore, my X is nothing but the amount of blood, right? So we know that in average 5.2 will be there in normal human being. Therefore, this is my average mean, right? So the mean mu is already given. That is average, which is 5.2. Okay. The standard deviation sigma is also given, that is a 0.3. So read the problem and write down everything in symbolic way. Now, what is the question actually? The question is you need to find out the percentage of the people. That means the probability, right? The probability of the persons, their blood level is less than 5.4. So if you have such a problem, first of all, draw a normally distributed curve, because we know now x is normally distributed. It is given in the problem. Therefore, I am free to draw, the normal distributed curve. Remember now, unlike in 6.1, now you don't have 0 here. This is now not z, this is x, right? X stands for normal distributed now, not standard. This is normal distributed. Okay, so now the question is you need to find the percentage, means the probability of the people being the blood amount which is less than 5.4. Remember, we had last time the midpoint of the normal distribution is going to be mu, but the mu value is now given 5.2, right? So it is given 5.2 in the problem. Now question is, now you need to find out the area which is less than 5.4, since this is 5.2. So 5.4 will be somewhere here. Okay. So now the question is finding the area of the region which is less than 5.4. Therefore, we need to find out, this area, right? Okay. So now find the percentage of, the blood level which is less than 5.4. You can't use the table at this point, right? Remember, table for standard normal. So what I'm going to do is I'm going to change, this picture into standard normal, right? How can I change? Okay, so we are going to change by using the relationship between standard normal z and normal distribution variable x. So I'm going to use this formula, right? Okay, so when x is 5.4, so I'm going to find this point in terms of z. When x is 5.4, then what is z? I'm just simply plugging 5.4 in terms of x, so they're going to replace x by 5.4, subtract the mean of the problem. Mean is 5.2 given, then divide by the standard deviation is 0.3, right? Now take your calculator, find this answer to two decimal places. So what is that? That is 5.4 minus 5.2 is 0.2, right? So 0.2 divided by 0.3 is 2/3. So what is that? 2/3 is 0.67, I believe. It is 0.67. That means if you convert this the new picture, okay? I'm converting the new picture. So now my new picture is for z. So now, if you draw the standard normal now, the middle point is 0. Now, the corresponding 5.4 in x will be now 0.67. So I'm changing now, I'm changing that earlier picture into now the distributed, variable picture. So here now my area is, now I need to find out this, okay? This is the area now I want. Now we know how to find area. Since this is standard normal, you could use either the table or calculator. So calculator will be a normal CDF, and you type the bounds. Now my lower bound is infinity, so negative E99, and my upper limit is 0.67. Okay. So now take your calculator and to find out this answer. So I'm going to normal CDF and negative E99, comma 0.67. So this will give you the area um, three decimal place is 0.749. Okay, so this is the area, but they are asking in percentage. So if you want to change, the numbers to percentage, simply multiply by 100. So that is simply multiply this answer by 100. So you will get 74.9 percentage. What does mean by that? That means 74.9 of the people, right, will be less than 5.4 Z amount. Will have less than 5.4 Z amount. Okay, that's the meaning. So this is the way to, find. First, read the question carefully, identify mean and standard deviation, and draw the picture for normal distributed value. Then change that into standard normal by using the formula and find the corresponding values. Okay, and you will find the area. But anyway, there is another method. You could do this problem without changing into standard normal. So let me explain that method. The second method is straightforward. So I'm not going to change into standard normal. Simply, I'm going to do the problem as it is with original variable x. So remember, my question is now, this is 5.2. I had here 5.4. So my problem was to find the area of less than 5.4 values, right? So we could use the calculator, directly to find this area. Again, I'm going to use normal CDF, but the area here, you have to, use the normal CDF function, but you need to put some parameters here. First, put the bounds for the area. So you put the bounds. The bounds are negative E99. That means the negative infinity to 5.4. That is fine. But after that, you have to define here the mu and the mean and the standard deviation, right? If you do not type mu and standard deviation, the calculated default value is 0 and 1, so it will consider always being standard normal. But remember, now I don't have standard normal. Now I have normal distributed, right? Therefore, I had a mean here, mu was 5.2, and the standard deviation little sigma was zero point 0.3 for this problem. Therefore, you need to type these two values after putting the bounds. So that is 5.2 mean and zero point 0.3 standard deviation. Okay, zero point 0.3 standard deviation. So this is mu value and this is standard deviation. Okay. Okay, then let us type this all into our calculator. So, normal CDF and negative E99, 5.4, the mean is 5.2, and the standard deviation is 0.3. Then just enter. So the area is the 4 decimal places or 3 decimal places is going to be 0.748. Okay, so if we convert into percentage, it is 74.8 percentage, right? Very close to the previous answer, but it's okay. So you could use in either way, directly using the calculator without changing into a standard normal, or just change into standard normal and then use the normal CDF without putting the parameters. Okay, so that is up to you. So you could choose any one of these two methods. Now let's look at the second example. So each month, an American household generates an average of 28 pounds of newspaper for garbage or recycling. Assume that the variable is approximately normally distributed and the standard deviation is 2 pounds. If a household is selected at random, find the probability of its generating. The first one, you need to find the probability of having the values between 27 and 31, and the second one is more than 30. Okay, since the question is about normal distributed, so you are free to draw the normal distributed curve. So the given information is the variable is normal distributed. What is my variable here? The variable is what they're talking about the amount of the newspaper, right, in terms of weight. Therefore, my x here is the amount of the newspaper. That is my variable here. So the mean of this problem is average, which is 28, and the standard deviation is SD is sigma, that is given, which is 2 pounds. Now let us draw the picture for the first part. The first part says that find the area. Probability means area, right? You need to find out the area between two values. Now first let me draw a normal distributed curve. Now my variable is normal. Therefore the middle point is my mean, which is 28. Okay. So now you need to find out the area between 27 to 31. So 28 is here, therefore 27 will be somewhere here. And you need to find 27 to 31. 31 should be right side of 28, so 31 should be here somewhere. Therefore, we need to find out the area between 27 to 31. So this is the area we need, right? Okay. So you could do this problem in both ways. First method, you could change, so let me do this problem in both ways. Okay. So the first method, I'm going to change the x variable into z variable. So I'm using the formula x minus mu over little sigma. So now I need to, look at your area. You have two values, right? 27 and 31. So you need to change those two in terms of z. So first, when x is 27, so I'm finding the z value using the formula. So when x is 27, I'm replacing x by 27. And we know the mean for the problem is 28. Deviation, standard deviation is 2 for this problem. Therefore, you need to divide by 2. So that is a negative 1 over 2, so negative 0.5. Okay, so that is one value. Now find the z value when x is 31. So again, I'm using the formula. I'm finding the second z value. So that is x is 31 and the mean is 28. Again, over standard deviation is 2. So that is 31 minus 28 will be 3, right? 3 over 2. So that is 1.5. So I'm finding basically two values. Now I'm going to change the picture. Now I'm going to change this normal distributed picture to standard normal. Since this is standard normal, I'm using z and the middle point is 0. Now the 27 for x value is now going to be corresponding value for z is negative 0.0, negative 0.5, right? And for 31 I got 1.5, that is my 1.5 for z. So now my area is nothing but the standard normal area, negative 0.5 to 1.5. Therefore the area here is normal CDF. Okay, which is negative 0.5 to 1.5. So take your calculator and find out. So second war CDF and negative 0.5, 1.5. So which is 3 decimal places will be 0.625. So this is the probability of the value between 27 and 31. Okay, so changing x into z. But in the second method, you could do this problem without changing into into z values. So now let me draw one more time the picture. Now remember, I'm doing the problem straightforward without changing x into z. So I'm drawing the original picture. This was 28, and we wanted to find the area between 27 to 31. So this is the area I wanted. So I'm directly using my formula. So therefore, that area is my probability, which is I'm going to use the normal CDF. Okay. So my left bound is 27 and my right side bound is 31. But if you use the formula normal CDF for normal variable, you need to define the mu and the standard deviation, right, in order, put into proper order. First mu, then standard deviation. So mu for this problem was 28 mean, and the standard deviation was 2, and put all four values in order. Therefore, what is that? 27, 31, 28, and 2. So this will give you the same answer, whatever you got earlier, 0.625. Okay, so this is very much easy, easy way to find the area. Okay, so you could choose either way. Okay, let's move to the next one. Now, finding the data value if you are given the specific z value and and the probability. The formula for finding the value of a normal variable x. So we already have the relationship between, remember, if we know x value, then we know how to find z, right? But this is in another way, backwards. Suppose if you know z value, then how do you find the x value? So x is simply given by the z value times the standard deviation of the original x, and you need to add the mean value of the original data, variable x. So this is the formula you could use to find the x value. X is given by z times standard deviation plus mu. Okay. Now this is the procedure to find the x value. Suppose if you know the probability or the area. Okay. So if you want, you could use the inverse norm function, right? Last time we saw how to find the z values if you know the area. Now you could use the similar procedure here. If you know the area, you could, use again inverse norm function. But if you want to find the x value, now you have to define your, the standard deviation and this, the mu into your formula. Okay. So now this is the procedure actually finding the data values for the specific probabilities. Draw a normal curve and shade the region, the given region. Then find the z value for, for that for that given area, then calculate the x value by using the formula x for the formula for x. Okay, so let's look at this problem. For a medical study, a researcher wishes us to select people in the middle 60 of the population based on the blood pressure. Assuming that the blood pressure readings are normal distributed and the mean systolic pressure is given and the standard deviation also known h, find the upper and lower readings that would qualify people to participate in the study, right? So if you draw the picture for this problem, it should be like since this is normally distributed, so I could draw the normal curve. Now we are going to check the 60 percentage of the middle guys, right? But we don't know upper and lower orders. So this is the question. Let me explain first. We already know the mid portion area, percentage means area. So we are going to look at 60 percentage of the mid portion. So 60 percentage means if you divide by 100, it is a 0.6, right? So you know the area. The question is like that. If you know the area, then how are we going to find these two endpoints? That is the question. So we don't know this point. Say this is x1 and x2. I don't know. So we need to find out x1 and x2. But you know the mean of this problem, right? Middle point. The mean is 120. Okay. So remember my x1. Okay. So now the thing is, you need to find out the middle portion, right? So how are we going to find it? Remember, they are telling that this is the mid piece, right? This is the middle 60. Therefore, this side is going to be, 20 percentage, and that side also going to be 20 percentage because mid side is, 60 percentage. The remaining out of 100 is 40 because of, the symmetric this picture. So we are going to have 20 percentage that side and 20 here. Okay. Now, what is our task? Our task is to find now x1 and x2. Okay, so we don't know x1 and x2. So these are the two values now we are going to find out. The procedure says what? First draw the picture and identify z1 and z2. So I'm going to change, this picture into z1 and z2. Remember, for my standard normal, I don't know the two values. Let me call this as z1 and z2. The mean is 0 for standard. Now this is my corresponding area. There I have 60, right? So this is the area I have now 60, that is 0.6. So again, this is 20 percentage and this is 20 percentage. Now, once you change into Z graph, it is always easy to think about. Remember, this graph is symmetric, right? But since I have 0 in the middle, therefore Z1 and Z2 will be this, the same quantity with the opposite sign, right? Z1 may be negative, but Z2 also should have the same value, but the positive, because of the symmetric about the 0. Let us figure out the z1. Remember last time we had, if you know the left area of the curve, you know how to find the corresponding z value, right? If you want to find the z value, you have to use the inverse norm function. If you want to find the area, then you have to use a normal CDF function. Now I know the area left side of the z1, which is 20 percentage. So 20 percentage is nothing but if you divide by 100, which is a 0.2. So you know the left area 0.2. So let us find then C1. So Z1 is nothing but use the inverse norm function, but you need to put the left side area, which is 0.2, right? So you don't need to put mu and sigma because this is standard normal. For standard normal function, you don't need to define mu and the standard deviation. So then this will give you the standard normal value for Z1. So what is that? Let us find in two decimal places. So I'm going to inverse norm function, and the left side area is now 0.2. Then close the parentheses and find out. Yeah, that is negative 0.84. Negative 0.84 is my Z1. If Z1 is negative 0.84, so this is negative 0.84. If Z1 is negative 0.84 because of the symmetric, now I could say that Z2 is positive 0.84. Okay, why is this? Because of the symmetric. Okay, so this is very easy once you change into Z because you are finding only one value, Z value. Once you know one value, another one will be, the same value with the opposite sign. Okay, since I have Z1 and Z2 value, now it is very easy to find X1 and X2. Remember my original question was finding X1 and X2. How do you find X value? Well, I'm using the formula. So we have the relationship between X and Z. So X is given by the Z value times the standard deviation plus mu, right? So, but I know the standard deviation for the original problem. For the original problem, standard deviation was, 120, right? So the standard deviation was 8 and the mu was 120. So if you plug in these two into your formula, so you will find the corresponding x. So if you want to find x1, remember, if you want to find x1, you have to plug in z1 here. because z1 corresponding to x1 and z2 corresponds to x2. So I'm finding x1, therefore you need to put the z1 value here times standard deviation for the problem is 8 and plus mu was 120. What is z1? Just now we found z1 is negative 0.84. You need to multiply by 8, then plus 120. This will give you, x1. Okay, so let us find out that value. So negative 0.84, then times 8, then plus 120. So that is 113.28. So 113.28 will be my x1. Now I need to find x2 also. Again, I'm using the same formula, but for x2, you need to plug in our corresponding z value, which is z2 times sigma plus again mu. What was z2? Z2 is now positive 0.84 and times the standard deviation was 8 plus mean was 120. Find out this answer. So 0.84 times 8 plus 120. So this will be 126.72. So these are the two values, okay? Okay. But anyway, you could do this problem without changing into z as well. So let me explain that one now. Remember, I'm always, giving two different ways to find out the solutions. Now the second method for this problem, without changing into z. Okay, remember, let me draw the original picture. The original picture was, like this. This was x, and sorry. And the mean was 120, and we are asked to find x1 and x2 such that the mid area is 60 percentage, that is if you divide by 100.6. Okay, so mu was 120 and the standard deviation for this problem was 8, right? Now I'm doing this problem without changing into standard normal, without changing into z. So how can I do that? Okay, I'm going to use inverse norm function directly for the x variable. But if you want to use the inverse norm or normal CDF functions for the x variable, normal variable, then you need to define the mean and the standard deviation for for the problem. If you want to use for the standard normal z, then you don't need, because calculated default value is 0, 1 for standard normal, right? Okay, so now my left side area is 20 percentage and right side also 20 percentage. Okay, remember, if you want to find x1, you need to know the left area to that point, right? So the left area to that point is 20 percentage, which is 0.2. Okay, therefore my x1 is nothing but inverse norm function of the left side area of x1, which is 0.2, but you need to define now here mu and the sigma for the problem. Mu was 120 and the sigma was 8. So it will directly give you x1 answer. So let us find that. So going to inverse norm and left side area is 0.2. Then command the standard deviation, sorry, the mu average for this problem is 120 and the standard deviation is 8. Simply find that. Yes, it is 113.27. So remember, in this first method, we got 113.28. It doesn't matter, very, very close, right? Both answers are. So this is very, very, very much straightforward. Okay, then the catch is now finding x2. How do you find x2? Remember, if you want to find x2, you need to plug in the left area to that point. What is the left side area for the point x2? You need to think a little bit. x2 is here. So the left area to that x2 is, let me color one more time, everything left side to that point, including that uncolored. So this is the left side area for x2. Remember, the middle piece area was 60 percentage, 0.6, and the remaining tiny area was 0.2, 20 percentage. So in total, you will have 80 percentage, right? Left side to that x2. So you have to consider all the values, all the region to that, left side to that x2. Therefore, which is 80 percentage, that is a 0.8, right? So the left side area to x2 is 80 percentage, which is a 0.8. Okay, therefore you need to plug in left side area as 0.8. So that is inverse norm, and I'm typing now the left side area to x2 is 0.8, and again 120 and 8. So the 0.8 is nothing but the left side area of x2. Okay, so now take your calculator, find out this value. So which is 0.8, comma 120, comma 8. So that will give you 126.73. That is my left point, right point, x2, right? So look at the previous answer, we got 126.72, very close, yes. So this is straightforward method. So you could catch, either method. Okay, so please, you can go over all the exercises and let me know if there is anything difficult.